the first thing I'm going to write, don't copy it down, okay? I'm going to tell you how it's set up, then show you what to do. So right here should be where your little spiral is. Like you should have it open like that. Okay, the left side, don't write this down, I'm going to write something. The left side will always be notes. The right side will always be where you put your homework. So that way when you're doing your homework on the right side, your notes are right there next to it, okay? If your notes take more than one page, you flip it, go to the next left side. Does that make sense? Do you understand what I'm saying? Okay, so on the homework side, I do want you to write something. So here's your, the top line, right? You're going to write NS1 through NS10 because that's tonight's homework. That's where you will be doing tonight's homework. Okay. Yes. Just the first page. Now, if you don't have a notebook, that's okay. If you need to take a picture of this to remind yourself, you can do that. But for tonight, you will just do your notes. Your notes and your homework on a separate sheet of paper. Okay, this way you can just keep everything all together. We know where it is. If you have your notebook, pretty much you have everything that you need for us. Okay. So on the right side, you'll do tonight's homework. On the left side is where we're going to start our notes. And we're on that top line, we're going to write today's lesson. So the title of today's lesson is 3.1, placing numbers on a number line. So write 3.1, placing numbers on a number line, and write today's date, just so you know when you took the quiz. This is today's notes. The objective and essential question are there for you to see. You don't have to copy it down if you don't want. We have some words here. You don't have to write everything down. Please don't write everything down. I know you're going to try it every time. Don't do it, okay? So we're going to talk about real numbers. It's important to be able to talk about them in various forms and compare them to other real numbers. We're going to start with integers and decimals. Do you know what an integer is? A number, no decimal, no fraction, just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all integers, okay? So first is example 1. We're going to plot these on a number line. Make a number line, copy these numbers down, and we'll plot them together. I know you might be able to do it by yourself, but it's just a refresher to make sure we're all on the same page. First is -4, 0, -0.5, 1.3 with a bar. What does a bar over a number mean? It continues on forever. Yeah, so 1.3 with a bar looks like this. And then pi minus 1. What is pi? 3.14. Good. So I have 3.14 minus 1. And what is that number? 3.14 minus 1 is what? 2.14. Awesome. Okay. So you should have your number line created, or you should be in the process of it. And now we are going to plot these numbers. Okay. So -4, where does that go? At -4. Okay, good. It's not a trick question. I really want to make sure you know what we're doing. Because come December, you're going to forget everything you ever learned in math, and that's why we're doing it now. Where does 0 go? That's a little bit concerning. Where does 0 go? Yeah, in the middle at 0. Now, what about -0.5? Between -1 and 0, and is it closer to 1, closer to the other, or exactly halfway? Exactly halfway. Good. What about 1.3 repeating? Where does that one go? In between 1 and 2. Where is it closer to? 1. A little bit closer to 1, about here. And finally, pi minus 1. We said that's about 2.14. Where does that number go? Closer to 2? Is it bigger than or smaller than 2? Bigger than. So it's going to go about here. We okay so far? Okay. Okay, plot these real numbers on a number line. I'm going to give you about a minute. If you need help, ask your neighbor, but it's pretty similar to what we just did. We'll go over the answers. Okay, did we all plot 3 correctly? I really, really, really hope so. What about -1? Yeah? Okay, 1.8, where does that go? Between 1 and 2. Closer to 2. Awesome. Negative 3.3 repeating. Between negative 3 and negative 4, closer to the 3. And then pi plus 2, what is that approximately? 5.14, so that is greater than 5, but very close to it, okay? Can I get a thumbs up, down, or anywhere in between for how this was? Awesome. Now to a block of text. You don't have to write the whole thing down. Okay, we're going to add in rational numbers as fractions. I love fractions. I know most of you do not. But you need to learn to at least get along with them, okay? The easiest way to think about rational numbers in this form is to consider the value as a decimal. So when we talk about a fraction versus a decimal, so if I give you 1/2, can you tell me that as a decimal? 0.5. Good, thank you. While it's important to be precise, we can often estimate or use an estimation. And you guys were already doing that when I said, what numbers is it between? You said between 2 and 3, closer to 2. That's a good enough estimate for me in these cases. Sometimes you need an exact answer. But when replacing them or just looking for the approximate value, that's okay. So we're going to need a rough decimal estimate, and we're going to do those right now. Okay, here, I'm going to have you copy this down, but please wait first. We're going to go through it, and then you can copy it, okay? So here are our common fractions. Don't write anything yet. I will give you a few minutes afterwards. First, we have 1/2. So we have 1/2 and 2/2. What do you think comes after 1/2? 1/3, which is 1/3, 2/3, 3/3. I know it's basic, but you still forget it. How many years after you learned it? That's why I'm going over it again. What comes after 1/3? 1/4. Awesome. So I have 1/4, 2/4, 3/4, and 4/4. And as long as I can remember, I've done 1/4 or quarters by thinking of money, 25 cents. That's the easiest way for me to remember it. It might be something that you want to start doing. Finally, we have 1/5, which is 1/5, 2/5, 3/5, 4/5, and 5/5, okay? Now the number lines. There's one for a fraction and one for the decimal values. You can make one number line and then write fractions and decimals on the same one, okay? So here's our halves, our thirds, our fourths, and our fifths, okay? So I'm going to give you, we're going to do our first example. So we're going to look at 8/3, okay? It's nice to know a precise answer, but we can also approximate it. So we're going to look at fractional equivalents around 8/3, okay? So I want to write the number 1 as a fraction. And I want to write it as a fraction with with a denominator of 3, because I'm looking at 8/3. So how do I write the number 1 as a fraction with a denominator of 3? 3/3? Did I hear someone say that? Yeah. Like that, right? What about 2? How would I write 2 as a fraction? 6/3, good. And what about 3 as a fraction? 9/3, good. Now, can I plot 8/3 on this number line? Yeah, where does it go? What is it between? Between the 6/3 and 9/3. Which one is it closer to? To the 9/3, like this, right? Okay, can you plot that for me? Can you do this number line? Let's look at 31/16. How can I write 1 as a fraction? 16/16, is that true? How do I write 2 as a fraction? 32/16, good. And now can I place 31/16 on that line? Where does it go? Between 1 and 2. Which one is it closer to? 2. It's really, really, really close to 2, right? It's almost 2. Example 3. Plot these numbers on the number line, then write them in order from least to greatest. So we said 8/3. If I write my fractional equivalents again, that was 3/3, 6/3, 9/3. So I had this, yes? Okay. My next one was 16/16, 32/16. So it was very close to 2, right? We already did those 2. What about the third one? Where does 99/100ths go? So, it's close to what? 1, because 1 is this, isn't it? So it's very, 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 very close to 1. And then my last one is 15 over 7. So 1 is what number? What's this fraction? 7 over 7. 2 is 14 over 7. And then 3 is 21 over 7. So you said it's where? Closest to 2. And is it bigger than or smaller than? It's a little bit bigger. So here is my 15/7. And I'm just going to write it in order now from least to greatest. So from left to right. Okay? And that is my answer. Okay, you're going to plot these ones and order them. 5/3, 10/4, 3/4, and 25/6. Now, on the last example, I wrote all my fractional equivalents. Do I have to do that every single time? No. I did that so you could see where they are. But if you can do them in your head and then plot the points, that is perfectly okay. I'll give you a minute to do this one. Okay, 5/3 is between what two numbers? Between what two numbers? 1 and 2, what is it closer to? 1. It's closer to 1 or is it closer to 2? It's closer to 2. Where does 10/4 fall between? 2 and 3. And what is its relationship between those two numbers? Where is it? It's closer to 2? It's in the middle. That is exactly half. What about 3/4? Or between 0 and 1? Where? Closer to 1, yeah, because that's 75 cents. And 25/6. Where does that fall? Between 4 and 5. A little bit closer to 4. So here's how we ordered our numbers. How do we feel about that? Were we successful? Yeah? Okay. Now we're talking about irrational numbers. Okay? Now I'm talking about radicals. Numbers that I can't take the square root of. Do you know what a perfect square is? Can you give me an example of a perfect square? 4. I heard a 16. What about 5 is a perfect square? 25. Yes, 25 is a perfect square. So those are numbers that I can take the square root of, and it's an exact value. Irrational is a number I can't take the square root of. It will give me a number that continues on forever, okay? So if we're looking at these, don't copy this number line. You'll get it on the next slide, okay? But I do want you to go through it with me. The square root of 0 is what? 0. So that's where it goes. The square root of 1, the square root of 4, the square root of 9, the square root of 16, square root of 25, square root of 36, square root of 49, 7, square root of 64, 8, square root of 81, and square root of 100. Okay, do you know all of these? I hope you know them. They will keep coming back. You really do need to know them, okay? So, if we look at this, you don't have to copy this one down because we'll get it in a few examples. Where does the square root of 8 lie on the number line? Between 2 and 3, thank you. And what's it closer to? Closer to 3 because 8 is very close to 9. So it's about here, you agree? Okay. Next, we have square root of 17. Where's that one? Between 4 and 5. What's it closer to? Much closer to 4, right? Not too bad. Do you know what the square root of 17 is? You can't do it in your head, right? You could do it on a calculator, of course. But I know it's very close to the square root of 16. So it's probably 4.1 or 4.2. I can approximate it. But I just need to know where it lies on the line. I'm not asking you for an exact value, okay? Here, we have example 5. Plot these irrational numbers on a number line, okay? So I want you to copy down this number line. You don't have to put all the tick marks in between. That was just for your convenience. But if I fill in all of the perfect squares I just had, I'm going to write all of these here as well, okay? So I'm going to put these so you have some frame of reference. Okay. This isn't a you try, but if you think you can do it by yourself, you can start it. I will go over it with you. We have one more example after this, a you try, and then we are done. Okay, so copy that down real quick. Uh-oh, hold on. Click the wrong button. And then to begin with, we found the first two on our last two previous examples. So the square root of 8, you told me, was a little bit smaller than 3, and the square root of 17 was a little bit bigger than 4, yes? Now we need the other ones. Where does the square root of 33 fall between? 5 and 6? Where? A little bit closer to 6, but kind of almost halfway. So between about half, maybe about here. I think that's a good estimate. It's probably around 5.7 or so. What about the square root of 2? Where does that go? Where does the square root of 2 go? I'm letting you answer me, but I can start calling random numbers. I will do that next week. This week it's getting to know you, but next week I'll call on you. Where does the square root of 2 fall? Between 1 and 2, and it's closer to, good. But, so since I have 1, 2, 3, 4, it's closer to 1, but not too close to it. So maybe about here, and it's about 1.2, I think. That was probably a little bit too far. Let's move it to the left a little bit more. What about the square root of 51? 7 and 8? Where? Closer to 7, maybe about here. And finally, I have square root of 85. 9 and 10? Closer to 9, so probably about here. Okay, once you finish copying that down, make one last number line. Example 6 is a you try of rational numbers again. Okay, so example 6, last thing you try. I want you to plot the square root of 99, the square root of 34, square root of 26, square root of 5, square root of 68, and square root of 12. I'll give you about 2 minutes, then I will give you the answer, and we will be done. Okay, square root of 99 is just under 10. Square root of 34, a little bit less than 6. Square root of 26, a little bit greater than 5. Square root of 5, a little bit greater than 2. Square root of 68, a little bit greater than 8. And the square root of 12 is about between 3 and 4. Okay? Can I get a thumbs up, down, or anywhere in between? Okay. If you're in between, let me know what you need help with. If you need a hard copy, come get one.